Students, I am Suneetha, Assistant Professor of Chemistry from Kakatiya Government College, Hanamkonda. Today we are going to discuss about inductive effect and its applications. This is a subtopic of our topic, structural theory and organic chemistry. Now, let's start the topic. So, what is inductive effect? First of all, let us see. Inductive effect arises in polar covalent bonds. First of all, let us consider pure covalent bond, non-polar covalent bond, and polar covalent bond. So, what is non-polar covalent bond? Let us discuss. When a covalent bond is formed between two similar atoms, that is homoatomic molecule, then bonded pair is attracted equally by both the nucleus. It means bonded electron pair occupies two atoms is known as non-polar covalent bond or pure covalent bond. Example H2F2Cl2Br2 etc. we have already discussed. Similarly, the second type of the bond, that is polar covalent bond. When a covalent bond is formed between two dissimilar atoms, then bonded electron pair is not equally attracted by both the nucleus. That is, it does not exist exactly in between the two nuclei. So bonded electron pair is more attracted towards the more electronegative, and this results in the formation of a polar covalent bond. Examples HBr, HCl. We discussed such type of the molecules already. Now, let us consider this type of the bond. This is CX bond. One atom like X is there. Then what happens? In this, X is more electronegative than carbon. So bonded electron pair is more attracted towards X. Hence, this X atom, it gains partial, this is delta, that is partial negative charge, and carbon atom gains partial positive charge. So, due to more electronegativity of X atom, this bonded electron is more towards X. Therefore, this X atom gets partial negative charge, and this carbon suffers with partial positive charge. The molecule, this one, in there, in between carbon and an atom Y, there is a single covalent bond, sigma. Is less electronegative. This Y atom is less electronegative than carbon. Then what happens? The bonded pair of electrons is more attracted by the carbon. Hence, carbon attains partial negative charge and Y attains partial positive charge. Here, charges are, we are supposed to correct this. This is partial negative and this is partial positive. If Y is less electronegative than carbon, then what happens? Bonded electron, the bonded electron pair is more attracted by the carbon than Y. Therefore, carbon suffers with negative charge. This must be negative and this must be positive. Negative charge, and this Y suffers with partial positive charge. Has a permanent displacement of electrons, forming a covalent bond, that is a sigma bond, towards more electronegative element or group. So, inductive effect is a permanent effect in which a sigma bonded electrons are involved, where the sigma bonded electrons are transferred or displaced, permanently displaced towards the more electronegative atom. This is known as inductive. Now, this inductive effect is always transmitted along a chain of carbon atoms. The longest carbon chain in the inductive effect is transmitted. The inductive effect is represented by a symbol arrow visit, arrow which is placed in exactly in between bond, and this arrow pointing towards the more electronegative element or group, and this effect is negligible after C3. It is in the longest carbon chain. After third carbon onwards, the inductive effect is minimized. In this example, this is carbon and chlorine bond. This chlorine is more electronegative when compared to carbon. Therefore, this chlorine attracts the single bond, the sigma bond pair of electrons or covalent bond pair of electrons more towards itself. Therefore, what happens? This chlorine, it suffers with the delta negative charge. That is, it bears delta negative charge. That is partial negative charge. Then what happens to this carbon? This carbon gets partial positive charge. And this effect, that is this inductive effect, it does not stop at the C1 carbon. It will be induced to along the carbon chain. Then what happens in between the C1 and C2 also? Same effect, that is inductive effect, takes place. Because of that reason, what happens in this bond pair of electrons are attracted towards this carbon because it is in a positive charge. Then what happens? This carbon suffers with positive charge. The positive here this carbon also gets a positive delta partial positive charge. Similarly, then what happens, this bond pair of electrons are attracted towards this carbon, that is second carbon. Then what happens, this C3 carbon or third carbon also attains partial positive charge, partial positive charge. Then if we go, it goes like this in the longest carbon chain, but we can see that this inductive effect will be diminished or decreased. It will be less or reduced as we go along the carbon chain of the C3 or C4 carbon atoms. After C4, it won't be there. C3 and C4, it will be less, we can say. This is the transmission of inductive effect along the carbon chain. That is the decrease. Here we can see the decrease in the effect is denoted by using greater than the sign of delta. So here one delta positive, here two delta positive, here three delta positive, here four delta positive. Delta and these three. Four delta positive. So here 4 delta positive means the positive charge is less when compared to 3 delta positive. This is less when compared to 2 delta positive. This is less when compared to 1. So the positive charge on C1 carbon is more when compared to C2, which is more when compared to C3, which is more when compared to C4. We mean to say this. Next. So how many types of inductive effect are there? We have already discussed about this, as we are going to discuss about the applications of inductive effect. So we are once again going through this inductive effect. So types of inductive effect. What is inductive effect? How many types of inductive effect are there? We have already discussed that there are two types of inductive effect. The one is negative inductive effect, that is minus I effect, and second one is positive inductive effect, that is denoted by plus I effect. So inductive effect is of two types, minus I effect and plus I effect. This is capital I, minus I effect and plus I effect. So two types of inductive effects we can observe the molecules. First of all, let's discuss about the minus I effect. Minus I effect. Any atom or group which attracts electrons more strongly than hydrogen is said to have minus I effect. So, which group is said to be minus I effect group? Electron withdrawing or electron attracting groups. So, any atom or group of atoms, so simply we can say that the species which attracts electrons more strongly than hydrogen is said to have minus I effect or electron attracting or electron withdrawing effect. Here, let us see a few examples which come under minus I effect. So, which exhibit minus I effect. There, one is NO2 group, Cl, Br, I, F. This is COOH group. This is methoxy group. These are the different groups which exhibit minus I effect. Minus I effect. That is what they will do. They attract the electron sigma bond or valent bond electrons more towards themselves. They are known as minus I affecting groups or electron withdrawing groups or electron attracting groups. What is the order of minus I effect of all these groups that we can see in this order? NO2 group, which has stronger minus I effect when compared to cyanide, which is greater than fluoride, which is greater than chloride, which is greater than bromide, which is greater than iodide, which is greater than CF3 group, which is greater than OH group, which is greater than methoxy group, which is greater than I group, which is greater than hydrogen. So, any group which has greater affinity to attract the covalent bond electrons or sigma bond electrons towards themselves than hydrogen are said to exhibit minus I effect or negative inductive effect. So these are the different groups which exhibit minus I effect or negative inductive effect, and this is the order of minus I effect of various groups we come across in the organic chemistry. Okay, next. Let us discuss about the plus I effect. What is plus I effect? Positive inductive effect. Positive inductive effect. Here, these are the groups which are less electronegative than hydrogen and which are classified into plus I effect groups, and these are the groups which attract electrons less strongly than hydrogen are said to have plus I effect. They are also known as electron repelling or electron releasing groups. Electron releasing or electron repelling groups. Plus I effect exhibiting groups are called electron releasing or electron repelling groups. Okay, so any atom or group, that we can simply say that any species that attracts electrons less strongly than hydrogen are said to exhibit plus I effect. Whereas in the case of minus I effect, they should attract electrons more strongly than hydrogen. This is a difference we should remember. Okay, next, now let us see the different examples. So that is plus I effect exhibiting groups. Let us see. The first one is methyl group CH3. This is ethyl group C2H5. This is isopropyl group CH3 taken twice CH. Next one is CH3 taken thrice C. This is tertiary butyl group. So these are the different alkyl groups which exhibit plus I effect. Which exhibit plus I effect. Now, what is the order of plus I effect of all these alkyl groups? Let us see. This one, tertiary butyl group has greater plus I effect than isopropyl group, which has greater plus I effect than ethyl group, which has greater plus I effect than methyl group, which has greater plus I effect than hydrogen. So, tertiary butyl group has the highest plus I effect among all these groups. So, this is tertiary butyl group, whereas this is secondary propyl group. This is secondary propyl group. This is primary, and this is methyl, and this is hydrogen. This is decreasing order of plus I effect. Decreasing order of plus I effect. So these groups, they release electrons to the carbocations of the chain in the molecule. Hence, these groups are also known as electron releasing groups. So these are the groups which gives electrons to the carbocations. That is to decrease the positive charge in the longest carbon chain. These groups, they release electrons towards the carbocation of the chain in the molecule. Hence, these groups are also called electron releasing groups. And this the effect that is constituted to presence of electron donating or electron repelling groups is known as plus I effect. So what is plus I effect? The effect that is caused due to presence of electron donating or electron repelling groups is known as plus I effect. So examples, tertiary alkyl group. This is tertiary alkyl group, this is secondary alkyl group, this is primary alkyl group, and this is methyl group. So these are all the different examples which exhibit plus I effect. Next, what are the applications of inductive effect? That is, what is the importance of inductive effect in the organic chemistry? So there are three very important applications of inductive effect. There, the first one is strength of carboxylic acids, or simply we can say that what is the acidity of carboxylic acids. And one more, second one is basicity of amines, and third one is stability of carbonium ions. So there are three important applications of inductive effect. One is strength of carboxylic acids, acidity of carboxylic acids. Second one is basicity of amines, and third one is stability of carbonium ions. Here we are going to discuss about the first application of inductive effect, that is strength of carboxylic acids, acidity of carboxylic acids. So, how do you say that one carboxylic acid is acidic? Acidic. Carboxylic acids, they exhibit acidity by losing proton. The strength of the carboxylic acid depends upon the ability to lose the proton, ability it has to ionize and lose proton, and this ability tells us about the strength of that particular acid. So carboxylic acids, they exhibit acidity by losing proton, that is H plus. And the acidic strength depends on the stability of forming conjugate base. The acidity of the acid depends upon the stability of the conjugate base produced by the particular acid. So what is conjugate base of the acid? Conjugate base of the acid, here let us consider this is the carboxylic acid, RCOOH. If it loses this H plus, we will get RCOO minus ion, that is only known as carboxylate ion, and this carboxylate ion is the conjugate base of this carboxylic acid. So if the conjugate base produced by this particular carboxylic acid is strong, then it, it definitely easily, let me say, it easily loses this proton or donates this proton and exhibits acidity. So the strength of carboxylic acid depends upon the strength of the conjugate base produced by that particular carboxylic acid by the loss of proton. By the loss of proton. This point we should remember. Now, so here let us see the strongly electronegative group helps in replacing proton from OH of an acid, that is our COOH. From the COOH, H plus can be easily replaced when strong electronegative groups are present in that particular acid. So this makes the acid more stronger. Now let us see the examples. First type. First type is halogenated fatty acids are much stronger, much more stronger than the parent fatty acid. Acidity of halogenated fatty acids increases with increase in the electronegativity of halogen. This we will explain taking an example. So when we compare the normal acid with halogenated fatty acid, normal fatty acid and halogenated fatty acid, if we compare the acidity of these acids, we can say that halogenated fatty acids are more stronger when compared to normal fatty acids. So the parent fatty acid, the compared just number, acidity of halogenated fatty acid is more. Now, why? How? This we can explain with the help of inductive effect. Let us see. Here examples we have given. This is cyanoacetic acid, this is fluoroacetic acid, this is more stronger than this. This is more stronger than chloroacetic acid, this is more stronger than bromoacetic acid. Bromoacetic acid is more stronger than iodoacetic acid. This is more stronger than methoxyacetic acid, which is stronger than formic acid, which is stronger than acetic acid, which is stronger than propanoic acid. So when compared to this acetic acid, this fluoro, chloro, bromo, iodoacetic acids are more stronger. This sentence we have given here. Why? Because this fluorine is more electronegative and it attracts the bond pair of electrons from this bond towards itself. Similarly, chlorine, bromine, iodine also, because of that reason what happens in between this C and C also same inductive effect, that is electron withdrawing effect takes place, and that carries forward towards this OH bond. Because of that reason this bond becomes weak, O and H bond becomes weak, and this H plus can be easily lost by the acid. Because of that reason it exhibits the acidic nature. So whenever halogens halogen atoms are present in the fatty acid, they increase the acidity of the particular acid when compared to the parent fatty acid. The same sentence we have given here, and these are the examples we have discussed. Now let's consider, as the number of halogen atoms increases, what happens to acidic strength of the acid. Acidic strength of the acid, what happens? Let us discuss. Now, first of all, let us consider this one. This is trichloroacetic acid, this is dichloroacetic acid, this is monochloroacetic acid. You consider this acetic acid, 1, 2, 3. Alpha trichloroacetic acid, this is alpha dichloroacetic acid, this is monochloroacetic acid. Now let us compare the strength of these acids. Okay. Now this one, the inductive effect in tri-dihalogen substituted acid is more stronger than monohalogen substituted acid. So why? Let's consider this one first of all, monochloroacetic acid. Now this chlorine is more electronegative than carbon. Then what happens here? This chlorine atom, it attracts this bond pair of electrons towards this. Then what happens? This is only called negative inductive effect. Due to this minus I effect, what happens? This is a bond. It gets the effect of this minus I effect. Because of that reason, the bond pair of these electrons are shifted towards this. That is, this carbon atom, it attracts this bond pair of electrons more towards itself. Then what happens? This carbon suppose with positive charge. Then what it will do? It attracts this zero bond electrons towards this self. Then what happens? There exists positive. There arises a little positive charge on oxygen. It does not bear positive charge. What happens? This oxygen, it attracts this OH bond pair towards itself. Because of that reason, this H plus can be, this hydrogen can be easily removed as H plus. That is only called acidic nature of this particular acid. Now let us consider this dichloroacetic acid. Here minus I effect of only one chlorine atom. If we consider this dichloroacetic acid, there are two chlorine atoms. That is minus I effect is double here when compared to this particular one. Because of that reason, what happens? This loses this H plus very easily than this. Therefore, it is more acidic when compared to monochloroacetic acid. Okay. Now let us consider the third one. This one. This is trichloroacetic acid. Here minus I effect of one chlorine atom, minus I effect of second chlorine atom, minus I effect of third chlorine atom. So it is the minus I effect in this molecule is tripled. That is, when compared to the first one, here minus I effect is more. Because of that reason, what happens? This H plus ion can be easily replaced from this acid. Therefore, it acts as a strong acid when compared to dichloroacetic acid, which acts as more strong acid when compared to monochloroacetic acid. And we know that this halogenated fatty acids are more acidic when compared to normal acids. That is, this monochloroacetic acid is more stronger when compared to normal acetic acid without substitution. Okay, so here due to minus I effect of one chlorine atom, in this two chlorine atoms, in this three chlorine atoms, these are more stronger when compared to acetic acid. And among these three, which is more strong? This one, first one. Why? Because here three chlorine atoms are there. Minus I effect is more. Because of that reason, this is more strong acid when compared to dichloroacetic acid. And this is more strong acid when compared to monochloroacetic acid. Okay. Now, let us consider another type. Here, the inductive effect decreases rapidly as the group responsible for the effect moves away from the source. Okay, the strength of the acid is proportionately decreased. That is, the group responsible for the inductive effect moves away from the source. Then what happens? The strength of the acid also decreases. Now, let us explain this with the suitable example. Now, let's consider this. This one, alpha chlorobutyric acid. This is first carbon, second carbon, third carbon, fourth carbon. So, 4 carbon acid is butyric acid or butanoic acid, we can say. So, this is 4 carbon acid, where on the this is first carbon, this is second carbon, and second carbon, what is this? Purine acid. That is alpha chlorobutyric acid. This is alpha carbon, this is beta, this is gamma carbon. Okay. So, the carbon which is adjacent to functional group is called alpha carbon. This is not alpha carbon because this entire group is functional group, COOH group. So the adjacent carbon is this one. This is alpha carbon, this is beta, and this is gamma carbon. So this is alpha chlorine. Alpha chlorine atom is the alpha chlorine butyric acid. Butyric acid is common, butyric acid is the alkaline. Okay. Now let us consider this. Here, this is alpha carbon, this is beta, this is gamma. So, on beta chlorine atom is there, therefore, it is beta chlorobutyric acid. Consider this one. This is alpha, beta, gamma, and gamma Cl atom is present. Therefore, this is gamma chlorobutyric acid. This is simple N butyric acid. N stands for normal, that is straight chain, no branching. Okay. So, this is normal butyric acid. This is gamma chlorobutyric acid. This is beta chlorobutyric acid. This is alpha chlorobutyric acid. now, which is more stronger. It is more stronger. So what we say is rapidly as the group responsible for the effect moves away from the source, and the strength of the acid proportionately decreased. So here the group responsible for the inductive effect is chlorine. This is the source. This is OH bond is source. H has to be removed to exhibit the acidity. So from this OH bond, this chlorine is here. From this OH bond, this chlorine is away. From this OH bond, this chlorine is still more away from this OH bond. Then what happens as the inductive effect causing group, it moves away from the source. What happens? The effect of inductive effect decreases. Therefore, the acidity also decreases. So, therefore, in alpha chlorobutyric acid, chlorine atom is nearer to this OH group. Therefore, here minus I effect is more. Therefore, it acts as a good acid. Stronger acid, we mean to say. Now, if we consider this beta chlorobutyric acid, it is when compared to this one, this is away. Because of that reason, the inductive effect is less here. Therefore, here it is a less stronger acid when compared to this. So you can see this. It is stronger, greater than when this is this one. Now, let us consider these two. This is gamma chloroacetic butyric acid. So where this chlorine atom is still more away from this source, this OH bond. Because of that reason, what happens? This is less acidic, when less stronger acid when compared to beta chlorobutyric acid. And if we consider N butyric acid, there is no minus I effect. Therefore, its acidic strength is less when compared to all these halogenated or halogenated substituted fatty acid. Therefore, when we compare the acidic strength of these acids, we can say that as the distance from the source decreases, what happens? The acidic strength increases, or the distance from the source increases, the acidic strength decreases. This point we should remember. Okay, this is regarding another point of acidity of carboxylic acids. Acidity of carboxylic acids. Fourth point. Alkyl groups are electron releasing groups. Just now we have studied, that is the groups which exhibit plus I effect. So now let us consider these examples. This is formic acid HCOH, this is acetic acid CH2COH, and this one if we consider, this is propanoic acid CH3CH2COOH, and this is 2-methyl propanoic acid, and this is 2,2-dimethyl propanoic acid. Okay, so these are the examples. Let us consider. More the number of alkyl groups, plus effect is more. Therefore, the acidic strength will be less. Okay, now let us see this. Alkyl groups. Alkyl groups are electron releasing groups. So let us consider formic acid. Formic acid is much stronger, C greater than acetic acid. Similarly, propanoic acid and dimethyl acetic acid and trimethyl acetic acid. Okay, so let us consider this formic acid and acetic acid. Formic acid is stronger acid because there is no plus side effect. Here, if we consider acetic acid, one methyl group is there, therefore it releases electrons. It repels this bond pair of electrons towards this carbon. Therefore, the negative charge on this carbon increases. Then what it will do? It releases electrons towards this CO bond. Then what happens? It releases electrons towards this OH bond. Because of that reason, the OH bond strengthens. As the OH bond strengthens, this H plus cannot be easily removed from this. Therefore, its acidic nature decreases. So, when compared to formic acid, acetic acid is a weak acid. Now, let's consider this. Here, this is the methyl group. Here, ethyl group is there. The plus I effect of ethyl group is more when compared to methyl group. Because of that reason, what happens? This OH bond still becomes stronger. Therefore, its acidity decreases. And if we consider this one here, methyl groups are there, two methyl groups, the plus I effect is more, thus the acidic nature is less. Here still more plus I effect because of three alkyl groups, three methyl groups. Because of this three electron releasing or repelling methyl groups, what happens? This OH bond becomes more stronger. Thus, this H plus cannot be easily removed. Therefore, its acidic strength is less. So, as the plus I effect increases, acidic strength decreases. This we can explain with the help of these set of examples. Okay. Now let's consider next application of inductive effect. Another application of inductive effect, that is basic character of amines, basic nature of amines. Amines are basic in nature. How do you say that amines are basic in nature? Here amines are basic in nature because they have the tendency to accept H plus. That is, if an amine is there or in H2, if we add water to this, it accepts proton and forms RNH3 plus and OH minus ions. So amines, they act as bases because they are proton acceptors. As they are proton acceptors, they act as bases. Now let us see this. The basic nature of amines is due to the presence of unshared electron pair on nitrogen atom which accepts proton. Okay, so in amines, RNH2 is the general formula. Nitrogen atom, a lone pair of electrons is available for coordination with proton. Because of this, it acts as a base. Okay, so now the ability of this lone pair to attract the proton determines the relative basic strength of the amines. So due to plus I effect of alkyl groups, RNH2 law is present. Due to plus I effect of alkyl groups, then what happens? Plus I effect in the sense electron releasing or electron repelling groups. So these are alkyl groups, they repel, they release electrons towards nitrogen. Thus, the electron density of nitrogen atom of amines increases. Thus, it acts as a good base, or the strength of the basic nature increases. So, the nitrogen atom becomes strongly electronegative due to this plus I effect of alkyl groups. So lone pair of electrons on nitrogen atom in amines is more easily available than in ammonia. When compared to ammonia, in amines, the lone pair is more easily available. Therefore, amines are more stronger bases when compared to ammonia. So hence amines are stronger bases than ammonia. Okay. Now, the relative basic character of amines is not as fast, not as fast. We should be careful about this. So tertiary, according to this statement, actually tertiary amine should be more stronger when compared to secondary amine, which should be more stronger when compared to primary amine, because in tertiary amine three alkyl groups are present, secondary amine two alkyl groups, primary amine one alkyl group, in ammonia no alkyl group. So when compared to ammonia, these are all stronger bases. But as it contains three alkyl groups, it should be more stronger base when compared to secondary amine, which has two alkyl groups. It should be more stronger base when compared to primary alkyl amine, which has one alkyl group. So this is what we can expect from plus I effect of alkyl groups. But actually, this is not the exact order. This is not the exact order. So what is the order? Let us discuss. The order of these basic character of amines is secondary amine is greater than primary, which is greater than tertiary, which is greater than ammonia. So according to plus I effect, tertiary amine should be here. Tertiary should be more than secondary, more than primary, more than ammonia. This is what we expect. But because of steric effect, the secondary amine has the strong basic character when compared to primary, which has stronger basic character when compared to tertiary, which is greater than ammonia. So here this is a secondary amine, two alkyl groups. Here plus I effect is more, because of that this is more strong. And here primary amine, one alkyl group. Here if we consider this, there are three alkyl groups, but it is not having the highest basic strength than secondary and primary, because of alkyl groups are only this nitrogen atom. So k alkyl groups surrounding this nitrogen atom as they are present, then what happens? Basic nature of that particular amine decreases. Basic nature of that particular amine decreases. Actually, this methyl group should be directly attached to nitrogen. This methyl and this methyl. And here this is correct only. Here also N should be here and no H. Tertiary amines and ammonia. So secondary amine has is a stronger base when compared to primary amine, which is more stronger when compared to tertiary amine, which is more stronger when compared to ammonia. Okay. Now next one is about the aniline. Aniline and ammonia comparative basic nature. Basic nature aniline and ammonia. Let's consider. If we consider the basic nature of aniline and ammonia, aniline is a weaker base. You see, aniline, this is C6H5NH2, weaker base than amines, aliphatic amines, RNH2. So in aniline, lone pair of electrons on nitrogen is delocalized due to resonance. The lone pair on nitrogen is delocalized because of three bonds present in benzene ring. So due to resonance, what happens? These lone pairs of electrons are delocalized into the ring. Because of that reason, the lone pairs are not exactly available to nitrogen. Thus, its basic nature is less when compared to RNH2. So in aniline, lone pair of electrons on nitrogen is delocalized due to resonance. So lone pair of electrons is less available for protonation. Lone pair of electron on nitrogen is less available to accept the proton. Thus, its basic nature is less. So in aliphatic amine, resonance is not possible. In this resonance, the check of delocalization of electrons or resonance or mesomeric effect is not possible. Therefore, due to this electron releasing effect of this alkyl group, this nitrogen has uh, uh, the ability to accept a proton readily. Therefore, this RNH2, that is aliphatic amine, is more stronger base when compared to aniline, that is aromatic amine. So this is another important point here we should remember. So now let's consider the basicity of substituted aniline. So the basicity of substituted aniline is decreased when minus I effect group like NO2 is present in the benzene ring. In the benzene ring, minus I effect group like NO2, if it is present, then what happens? The ability of nitrogen to donate that lone pair, it decreases. Therefore, its basic nature decreases. Due to here, due to a minus effect of NO2 group, lone pair of electrons on nitrogen atom is displaced away from it. Because of that reason, its basic nature is less. So it is less available for protonation. Therefore, nitroanilines are weaker bases when compared to aniline. Now next one, basicity of substituted aniline is increased with the groups like plus high effect, groups which exhibit plus high effect like methoxy group. The plus high affecting the groups which exhibit plus high effect increase the electron density on nitrogen atom. Therefore, it attracts the proton readily. Therefore, it acts as a stronger base when compared to aniline. So, due to plus high effect of groups, electron pair on nitrogen atom is easily available for protonation. The compound becomes more basic than aniline. Hence, paramethoxyaniline is more stronger than aniline, whereas paranitroaniline is less stronger than aniline, whereas paramethoxyaniline is more stronger than aniline. Now, last one. This is stability of carbonium ions. This we can explain with the help of inductive effect. That is, let me say, plus I effect. So, due to plus I effect, the alkyl groups release electrons towards positive carbon and this reduces its positive charge. This is called charge dispersion. Plus effect, due to plus effect of alkyl groups, what happens? The positive charge on the carbonium ion, the positive charge present on the carbonium ion is decreased due to the plus effect of the alkyl groups which are attached to the positively charged carbon. Then this is only called charge dispersal. Due to charge dispersal, what happens? The stability of that particular carbonium ion or carbocation increases. So is it is based on plus I effect of the alkyl groups attached to that particular carbocation. So if we consider tertiary carbonium ion, this is the tertiary carbonium ion. If we consider the tertiary carbonium ion, three alkyl groups have more charge dispersal. Because of three alkyl groups, more charge dispersal we can observe. So this is tertiary carbonium ion. Here the carbon is there. Here CH3, CH3, CH3. This carbon suffers with positive charge. This is tertiary carbonium ion. Due to the presence of three methyl groups, due to plus I effect of three methyl groups, the charge dispersal is more. Therefore, it is more stable. If we consider secondary carbonium ion, there are only two methyl groups. There are only two methyl groups. Therefore, the charge dispersal on this carbon is less. Therefore, its stability is less when compared to tertiary. If we consider primary carbonium ion, this plus must be here. So this primary carbonium ion, only one methyl group is there, which exhibits plus I effect. Therefore, its charge dispersal on this particular carbon is less. Therefore, it is less stable when compared to these two. And there is no plus I effect we can observe. Therefore, it is least stable. So, due to plus I effect of alkyl groups, they release electrons towards positive carbon and thus reduce its positive charge, and this is only known as charge dispersal. And the tertiary carbonium ion with three alkyl groups has more charge dispersal, so it is more stable when compared to secondary carbonium ion, and which is having two alkyl groups, and primary carbonium ion with one alkyl group. So this has one alkyl group, this has two alkyl groups, this has three alkyl groups. Therefore, here more charge dispersal, therefore more stable. So methyl carbonium ion with no alkyl group is the least stable one. So we can explain the stability of carbonium ions based on the stability of alkyl groups. So the carbonium ion which has more alkyl groups or a more plus I effect is more stable. Okay. Therefore, tertiary butyl carbonium ion is more stable when compared to isopropyl carbonium ion, which is more stable when compared to ethyl carbonium ion, which is more stable when compared to methyl carbonium ion. Now, let's see what are the important questions which we will come across in the SEMEND examinations from the topic which we have covered today. Okay, so first one is, what is inductive effect? Explain the types of inductive effect. So we should write here the definition of inductive effect and how many types it is. So type 1 plus minus I effect, type 2 plus I effect, and type 1 definition and with examples, and type 2 definition and examples we should explain here for inductive effect and its types. This is the first question. This is very common question we will come across in the SEMEND examination. Most of the times in the SEMEND examination, it was asked. Now let's see the second question. How does inductive effect influence the basicity of amines? Explain with suitable examples. Just now we have discussed the basicity of amines based upon the inductive effect. Both will influence the basicity of amines. If a plus I effect is present, the basicity of amines increases. If a minus I effect is present, the basicity of amines is decreased. And next one is third question. This is, why tertiary carbonium ions are more stable than secondary and primary carbocations? Explain with the help of inductive effect. Just now we have discussed this. Tertiary carbonium ion with three alkyl groups with more plus I effect, it is more stable when compared to secondary carbonium ion with two alkyl groups with more inductive effect when compared to primary carbonium ion, which has only one alkyl group and one inductive plus I effect. So, like this, the tertiary is more stable than secondary, which is more stable than primary, which is more stable than methyl carbocation, which has no alkyl groups, therefore no plus I effect. Next one, aniline is weaker base than ammonia. Why? Aniline is weaker base than ammonia because in aniline C6H5 and H2, whereas C6H5 group is electron with the trying group, that is due to delocalization of electron density on a nitrogen atom. It is the electron pair on nitrogen is less available to accept the proton. Therefore, in aniline, the basic character is less when compared to ammonia. And next one, arrange the following acids in the decreasing order of their acidities and justify your answer. This is the question. So these acids, we should arrange them in the decreasing order of their acidity. So the first, the strongest acid we should select. So here, acetic acid, formic acid, propanoic acid, chloroacetic acid, and nitroacetic acid we have. So first of all, let us consider these three. Among these three, which is more strong? So alkyl group, this is alkyl group, this is methyl group, this is ethyl group. So as the bulkiness of the alkyl group increases, what happens? The plus I effect also increases. Therefore, here no alkyl group, only formic acid. Therefore, it is the strongest acid, no plus I effect. And next comes CH3COOH, because here the smaller alkyl group is there. Therefore, this is more stronger than this. And this is the first one, the strongest acid. So formic acid is more stronger than acetic acid, which is more stronger than what do we say? Propanoic acid. Propanoic acid. Now let's consider this ClCH2COH. This is chloroacetic acid. Chloroacetic acid, due to the presence of chlorine atom, that is chlorine atom is minus I effect. That is it attracts the bonded electrons, the sigma bonded electrons towards itself. Because of that reason, this H plus can be easily donated by this acid. Therefore, chloroacetic acid is stronger acid when compared to normal acids. That is, when compared to acetic acid, it is stronger. And next one is NO2. NO2 group, this is also electron withdrawing group, but it is a better electron withdrawing group when compared to chlorine. Therefore, it comes first when compared to this. This is also stronger acid. So, in the acidic strength, we should say that this is more stronger when compared to this. So this is more stronger when compared to acetic acid. And when compared to this acetic acid, formic acid is strongest. And here next comes CH3, CH2COOH. So this, like this, we should arrange the acids in the decreasing order of their acidic strength. So the from these three, formic acid is stronger than acetic acid, which is stronger than propanoic acid, and these are the acids which have a minus I effect. Because of that, these two are stronger acids when compared to acetic acid. So like this, we should arrange them. So formic acid greater than nitroacetic acid, greater than chloroacetic acid, greater than acetic acid, greater than propanoic acid. This is the order we should write. So this is about today's topic. What we discussed, inductive effect and its applications. So these are the different questions we come across in the SEM examination of first year, first semester of BSc. Okay, so next session with some other topic. Thank you.